microfarad, isn't it? Microammeter. And we've got a resistor which is labelled as yellow, purple, orange. Yellow, purple, orange, yes. So it's supposed to be 47,000 ohms, and it's got a gold band on the end. Gold band is plus or minus 5%. So before I go any further with that question, because I've read the first couple of words and it says it's within tolerance, I need to work out what 5% of 47,000 is. And you know, here with discounts, if you go into the shop, JB Hi-Fi, they'll say that there's 5% off the price of this. But you know, having lived in China, it's done differently overseas, and how they do it over there matches the mathematics that we need to use. They actually go 95% of the original price. Huh? How's that work? So, if we've got 47,000, instead of going 0.05 and subtracting it from it, why not just go 0.95 times it? It's much smarter. So, 0.95 times 47,000 equals 44650. 44650 is the low side. And the high side, how about 1.05 times that? 1.05 times 47,000 equals 4935. 49350 high. This is the range that the resistance can be between. It can be as low as that or as high as that. The manufacturer is telling us that because we were too crummy to buy the 1% resistor. We saved a few bucks and we bought we saved probably 2 cents to be honest, and we bought the 5% resistor with a bigger variation in the tolerance. So now that we've got those values, let's run some maths on that. I've got 5 volt supply and I've got supposedly 47,000 ohms, so I equals V on R. So 5 divided by 47,000 equals engineering button, 106.4 microamps. 106.4 microamps. Ooh, 106.4 microamps. But the question told me that we had 118 microamps flowing. Heck, that's a big departure from 106 microamps. Well, let's run the maths on that. If we've got the voltage and we've got the current, we can use those to work out what the actual value of that resistor is. So R equals V on I equals 5 divided by, I'm just going to be lazy and put that down to there. So 5 divided by 118 exponent minus 6. Finally, 42,372. R equals V on I, 5 divided by 118 microamps. So don't forget when you put that into your calculator, 118 exponent, sign change, depending on your calculator, 6 minus 6. 118 exponent minus 6. 5 divided by that. 42,372. Oh dear, look at the size of that. Look at the size of that. The resistor, once we work out the minus 5%, we get 44,650, but 118 microamps is telling me the resistor is in fact 42,372 ohms. It's way out of tolerance. It's out of tolerance by 2,000 ohms. Can you see it? A lot of vague looks on faces. Mahmood, what's up?
Camera turned off.
Camera turned off. Camera gone flat or screen just... When did it turn off? Just then?
Just now.
Just now. All right.
Screen just went off.
Probably it's got a 20-minute video time, I think, and then it stops.
I didn't get this whole thing.
Okay, part 3.
I got it right, but you marked it wrong.
All right, having restarted the video, and now we pray to the video gods that the battery won't go flat and it'll keep going, and no clouds will come in front of the sun, and the light will keep shining. You don't get it. All right, so I'm not sure where it cut out. I said R equals, we know that we've got 5 volts supplying the circuit. The circuit says there's 5 volts. Let's circle that, 5 volts. The circuit also tells me there's 118 microamps. R equals V on I. If I know the current and I know the voltage, I can work out the resistance. Agreed?
That's what I did, yeah.
So, we run the figures on that. 5 divided by 118 microamps. 118 exponent sign change 6. 118 microamps. 42,372. Get your calculators, work it out. Do it now.
So you marked it wrong from me. I did that though. I haven't got 106 microamps.
You didn't say why. You didn't. I circled it. You did not say
I
why.
do write it in the calculator.
It says show you're working.
This
I know
118
why,
next
I worked
power.
it out.
It depends on the calculator that you've got. Now today, I've picked up a TAFE calculator. It's an FX82 NASER, and it's got different button layout to yet another FX82 I've been using. This one's pretty weird. It hasn't got a dedicated button for X squared, and it hasn't got a dedicated button for 1 on X.
Can you show it here once on this calculator?
I'm just trying to work out.
So, you've got an FX82AU. So you've got to go, you mean to get the 5 divided by 106,
No, 118.
118. Let's start again. 5 divided by, that's what I was doing before, 118 exponent. That's your exponent button. How do you go back? Go back, go back. Yeah. Exponent, and on this one, you just go minus 6. 5 divided by 118 exponent minus 6. So your FX82AU allows you to use the minus button instead of on mine where I've got a little sign change button I've got to use. I think this must be a pretty old calculator. I'm pretty good with most calculators, it's just sometimes they throw me, I pick it up and I go, oh, this is a little bit different, I haven't used this one for a while. So once you get the head around the maths, and look, you can even put it in by going point 0.0000118. There's 118 micros, isn't it? No, it's not. That's 118 nanos. Ugh. 118. 118. There's the equivalent for 118 microamps, because don't forget this is millis, this is micros, and then the next group of 3 is nanos, and then the next group of 3 after that is picos. Wow. So 0.000118 is micros, but get used to using exponents on your calculator. You'll be using them next week with capacitors, and then when you go downstairs, if you get into the electrical course, you'll be doing it with the AC all the time. You'll be working with phasors and vectors and AC circuits, and you'll be using exponents every single time you turn your calculator on. So get used to using your calculator. What a good tip is if you can print the manual out for the calculator, and just before you go to sleep, you probably laugh at this, but just read 1 page a night out of the calculator manual. And in about 2 weeks, it's not a very thick manual, you'll learn every function on the calculator. Just 5 minutes a night. It's amazing how you can become productive. Sorry?
Where do we get that sheet?
Google. Just Google it. If you go onto Google and you search for the manual that comes with the calculator, and then print it. Or just read it off the screen. Huh. It's the same with your phone, you know. A lot of functions on your phone you never become too familiar with because nobody ever reads the manual. If you read the manual and you learn what all the different functions are, it's amazing extra shortcuts you could discover. Are we still going? with this thing? Oh, we are. Okay. It's probably got a 20-minute cutout timer, I think. How's our audio going? Our audio is looking good. We're down to 2 bars, but we're still okay. Are we okay with this question now? Do you understand what I did? I looked at the 47,000 ohm resistor. I did 5% down, 5% up to look at the tolerance. All right, you should have done this the day that I was away and you had the other teacher and you were doing resistors. Did you do tolerance that day with resistors? You don't remember it? I'm sure you would have.
It's pretty quick.
Pretty quick. You didn't do any exercises or anything?
We got the sheet with the colours on it.
Right.
Like we didn't like.
You didn't do an activity though?
We didn't do too much on it.
You didn't measure any with meters and do some activities with... Oh, look, oh, well, apologies. You probably would have been better if you'd done that. All right, let's move right along. There it is. The next question I can't put up on the board. The next question is, and I'll add it to the video. I'll just scan it in. The next question is with the Hioki analog meter, and it says the ohm meter is on the times 10k scale. Well, times 10 gives it away. I'm looking at the k scale for k ohms on the top, and it says 20k ohms. That would be 220, 240, 260. They're 20k divisions. That's 240. Looks like about 245. 24.5k rather, but then you've got to multiply it by 10. So there's no 24.5, there's only 240. It's 240,000 ohms. The scale as it is reading, say, 24,000 ohms, but it's on a times 10. There's a switch that says times 1, times 10, times 100. Times 10 scale, 240k ohms.
So I didn't get this. How do you read it?
This goes back to the notes we did right back in week 1 when we looked at analog meter scales. See where the 20k is, and it's got a solid division for 20k. And then the next division along to the left is going to be 22k. The next one would be 24k. But the question says it's on the times 10 scale. That's 24k times 10, which is 240k. Have a look back through your week 1 notes. There's lots of pictures of analog scales, and I remember we did questions in class. There was the ammeter and the voltmeter, and we looked at all the different minor and major divisions, and we did the exercises on it. Go back over that. That takes us to the last question, question 9. Question 9. This was the big question. Well, not really. It wasn't that big, but maybe it was a little bit hard. Same circuit again. 270, 470, 560.
You gotta use current divider on that one. You know?
I think you probably do.
I just worked it out.
Milliamps. The current meter reads 18 milliamps. 18 milliamps we're currently reading on the current meter. The battery voltage is, find V bat. Him. Find V bat. Ooh. Okay, where do we start with a question like this? Where do we start?
Always find the resistance total. Oh, you branch up, sorry.
I wouldn't be looking for the resistance total. Aiden, any idea where we might start?
Probably need the current and the resistors in parallel.
I wouldn't go down that track. I want you to take your mind back, right back to week 1, and I want you to think about this. Sometimes, you know, it's as plain as the nose on our faces, but fact is we can't see the nose on our faces. Somebody else needs to point it out to us. So,
V times I.
that was Asimov said that.
times also.
VIR. Can you see somewhere on the circuit diagram where I've got a current and I've got a resistor?
Yeah.
Where?
Current in the bottom.
Oh, look at that. Wow. I've got a resistance and I've got a current which is flowing through that resistance, yeah? So that means I can use V equals I times R. I times R. So 18 milliamps times 560 ohms, and that gave me 10.08 volts. And that's across here. .08 volts. Think about it, if I've got 10.08 volts across here, plus minus, that's in parallel with that. So that means that's also got 10.08 volts across. Parallel combination. Parallel network has the same voltage across each resistor. Yeah? So, that means I can draw now a set of parentheses across this network, 10.08 volts. Now what can I do? Matthew? No. Again, I want you to think about VIR. Can you see two variables that I can use to get a third? Alex? Oh, guys, don't go to sleep on me. I've got a current there. I've also got a current there. I've got a current there. The sum of those two currents adds up to that current up there. I know that current's 18 milliamps. I've got a voltage across that resistor. I don't know the current going through it. Can I work it out?
You sure can, mate.
Omar?
You should be able to.
Can you do it?
Not too sure, but
10.08 volts, 470 ohms. I equals V on R. 10.08 divided by 470 equals.
so I got 2.1. 2.1.
2.1. I don't think it's going to be 2.1. 10.08 divided by 470. 10.08 divided by 470 equals 21.4 milliamps. I think some of you guys have got a lot of work to do. 21.4 milliamps flowing down through there. Well, guess what? Now I can add the 18 milliamps to that. Add 18 milliamps. 21.4 add 18 equals 39.4 milliamps. So that 39.4 milliamps is what's happening up here. 39.4 milliamps is the main circuit current. That's this current here as well. 39.4 milliamps. 39.4 milliamps came in and it's split into those two branch currents. The battery voltage is, again, back to simple VIR. I know this resistance and I know this current. Can I work out the voltage across that?
Yeah.
V R 270 ohm is going to be equal to 39.4 milliamps times 270 ohms. 0.0394 times 270.
Rounded up, 11.
0.0394 times 270 equals 10.6. 10.64 volts. Well, you know what? I had 10.08 volts. I'm going to bring that across. Across my parallel network, I had 10.08 volts. I'm going to bring that down here. 10.08 volts. And I can add those together. 12, 7, 20. 20.72 volts.
I forgot, I didn't add mine up.
The answer is C, 21 volts.
Why did you add it up? Why did you plus it here? Is that the rule?
Because I've got a voltage across these,
Yeah.
and I've got a voltage across that. I have to add that voltage to equal that voltage. Kirchhoff's voltage law. The sum of all of the voltages in the circuit add up to the supply voltage.
Back to basics.
Back to basics. It's just simple basics. Any other questions about this? Look, that wraps it up. That's the 9th question. Honestly, a quiz like this, doing it in class in week 5, you guys, you should be doing this in about 20 minutes, 20 to 25 minutes tops. These are very simple, straightforward questions. So, if you're in Struggle Street with this, you know it now, and now's the time to do some study. Don't leave it another week. Don't leave it another day. Because what will happen will be in the last week, we'll be doing the final test, and you will not pass the final test if you can't do these questions. Because we are building on these questions from this time forward. We've got a major lab to do today too on series parallel, and we'll be using breadboard, putting resistors into a breadboard, measuring currents and measuring voltages using equipment. All right, look. We'll wrap it up there then. That was the last question. I'll make sure I post all 3 parts of the video on YouTube and on my website, and then you can go back and you can revise these questions. Please do so. Like I say, don't leave it till the last minute, because you can't do this at a minute to 12 at night time, then go to sleep at 12:30, and then the next day expect to know it. Isn't going to work. I've tried it. I can tell you, it doesn't work. You've got to do lots and lots of practice questions and go over it and over it so that you become proficient. Yes?
That's why I ask you, sir, do you mind, please, if you have spare time, to possibly give us some questions?
I've got some questions. Like last week I gave you out those questions. I've got some more questions today I'll give out. Plenty of questions from the Floyd textbook. All right, let's...
When do we
geez, I
find
need a
this,
glass of water.
video exactly on the site?
I'll let you know. I'll tell you exactly where to find it. Yeah. All right, let's kill it.